All right, we overloaded it. Today we're taking a look at the Anker SOLIX F3800 power station. Now this thing is extremely capable, and the first thing I want to tell you guys about right out of the gate is that this thing can actually output 240 volts. The fact that it can do that makes this thing extremely versatile, especially for anyone who lives in a rural location and relies on a well pump for their water. Previously, most of the power stations that were available were not able to do 240 volts unless you maybe had multiple units and connected them together. This thing can put out 6,000 watts of power at 240 volts, up to 9,000 watts peak, and that should be able to handle all of my 240 volt appliances. Not simultaneously, but individually they should all be able to run. So we're going to be connecting this thing to my power inlet box out in the yard. But as you can see, we are in the basement right now, and we need to get this thing connected to that power inlet box. So what we've got here is a very long, very heavy duty cord that is going to allow us to connect the output from this thing to the connection out in the yard. So let's go ahead and get this connected. Once I get this all fired up, we're going to come back and I'm going to show you guys all the ports on here and explain to you exactly what this thing is capable of, the expansion capabilities, as well as we're going to connect to solar. One of the reasons we have this thing sitting inside is that these things are not weather sealed, so we got to have this thing sitting in an environment where it's not going to get rained on or get a whole bunch of dirt and dust sucked into the unit itself. And since it's not producing any gaseous fumes like carbon monoxide and just combustion, it's no problem for it to sit in a space like this. Another thing to note is that if it's below 32 degrees Fahrenheit, you are not going to be able to charge these units. So you need to make sure that this thing is warm enough to be able to charge. All right, let's go ahead and connect this thing to the power inlet box. At the end of the video, we're also going to do a capacity test and drain this thing all the way down to 0% and see exactly how many kilowatt hours we're able to get out of one unit with one expansion battery. Now we're going to take our 30 amp generator cord, which is actually capable of handling up to 7,200 watts, and connect that to our power inlet box. I love hearing about people's setups with their off-grid or backup power situations, so comment down below and let me know, what is your backup power strategy? Do you have a gas generator, propane generator, solar, batteries, no batteries? What do you rely on? Comment down below. There will be links in the description to the Anker SOLIX F3800, expansion batteries and solar panels, as well as transfer switches and all the other accessories that you will need if you are interested in this sort of a setup. So definitely check those out. At the time of posting this video, you can actually get 35% off of whatever bundle you choose, either one that has more batteries or solar panels or transfer switches, by using the Kickstarter link in the description. So if you want to jump on this right away, you can actually save a decent bit of money. Now, November is actually the cloudiest month of the year in Minnesota. So the amount of solar power that we're going to generate is probably pretty minimal. I'm actually not sure if we're going to get any output right this second because we are not only cloudy, but there's also a tree blocking most of the sun. Obviously, if we had an actual power outage situation, I would be trying very hard to get the solar panel into direct sunlight as much as possible. But for now, we're just going to demonstrate the concept and send these wires into the power station. You can connect up to 2,400 watts of solar power to the Anker SOLIX F3800, which is actually really impressive. So this right here is the PS400 solar panel, and you can have up to 6 of those combined to connect into the unit. And that's actually the fastest way to recharge the SOLIX F3800. The grid input is actually only about 1,800 watts, so you can recharge faster if you have the proper solar panels than you can with the actual grid. We'll talk more about using the Anker SOLIX F3800 and the grid at the same time in a little bit. We'll go ahead and connect our solar input. All right, let's go ahead and get this thing plugged in. There we go, we're connected. Now the power inlet box outside is not turned on yet, so we're going to go out there in just a minute. And I think I'm going to go ahead and turn on our AC power to make sure that we're ready to go on that. So our 60 hertz power just came on, and let's go ahead now and go turn the power inlet box on. This is the moment of truth. Before we turn on our input power, I just want to take a quick look and see how many watts we're using. On the Sense Energy monitor, it's 1,128 watts. So that's how much energy we'll be pulling from the unit as soon as we switch over. If you guys want a Sense Energy monitor to mount into your panel like what I have, there's a $25 off coupon code in the description. For those of you guys who don't know, this is called an interlocked breaker for a power inlet box. I'll link to that video in the description if you guys want to see that. What this does is prevent us from backfeeding the utility. If you were able to keep this turned on and turn on the power supply from your generator or your Anker SOLIX F3800, what is going to happen if the utility is down, so if there's no power coming in, you leave this on and turn this on, you're actually going to backfeed power through this breaker into the rest of the electrical system, back through the transformer and out onto the utility lines, and that's obviously an extremely hazardous situation for the linemen. That's why you never want to use something like a suicide cord where it has a male connection on both ends to backfeed from a generator through a dryer receptacle or a welder outlet or something like that. It's a terrible idea. You should not do it. You really need to have an interlocked breaker or a proper transfer switch, which I'm going to show you guys a transfer switch, an alternate version of what we're talking about here in just a couple minutes. But let's go ahead and get this thing turned on. Okay, so what we got to do first is turn off the power coming from the utility. So here we go. And then we're going to lift this plate up and turn on our power inlet. And now we should be connected to the Anker SOLIX F3800 in the basement. Let's go check it out. Now the real question is, did Naomi notice that the power went out? Because if she didn't, that's kind of cool. And we can see how long we can go powering the house without her knowing that the power went off.
There was like a really big thump and like it felt like the house sort of imploded. Maybe it was the base over here turning off or something. There was like a sound and a feeling, like you could feel it. So I don't know what it looks like down there, but if there's smoke coming up, I think it's probably fine. And then a second later I heard everything turn back on, like power back up.
I think Naomi noticed. Okay, well there are lights on down here. That's a good sign. All right, let's see what we're drawing on here. This thing is perfectly silent right now, which that's actually a big deal. That it's perfectly silent, because some power stations will just run the fans all the time, even if it doesn't need them to be running, which is kind of weird. So yeah, it's working. The Sense Energy monitor came back online. We're using 900 watts. Now, one cool thing you can do with the Sense monitor is you can actually go into System and see exactly how many watts are being drawn by each leg. So you can see right there, leg 1 is 256 watts and leg 2 is 655. And that gives us a good idea of whether or not we're going to be balanced in how much we're drawing, because obviously you need to have a balanced load in order to get the full potential out of what this thing is capable of, because each leg is going to have 3,000 watts continuous available. So if you overload just one leg, you're going to lose out on the other 3,000 watts of ability that this thing can handle. This pressure gauge shows our current pressure inside of our well pressure tank. It is currently set up as a 3050, so once it gets below 30 psi a little bit, it should come on, and we should be able to see the wattage increase. You can see right now we're at about 830 watts. I'm going to go turn on some water, and we'll see when the well pump comes on. Now this is totally unplanned, but the water heater actually came on while I was heading up to turn the water on in order to make the well come on. So we've got that 4,400 watts drawing right now, and the well hasn't even started yet. So right now we're at 4,000 watts? Something else must have turned on at the same time. Okay, 5,000 watts, why? So I believe what we've got going on right now is our electric water heater has turned on, plus our well pump, which was an additional 380 watts. So we are close to the maximum capacity of what this thing can do at over 5,000 watts right now. I'm going to go ahead and turn off the water heater and see if that is what is currently running. Yep, most definitely was the electric water heater. I'm going to go turn off the water now. There we go, you can see the well did just shut off. So at this exact moment we are drawing 230 watts and 440 watts on our two different legs. Let's go ahead and turn the heat on. Now this is going to actually turn the heat pump on, so it's the same as like turning on your air conditioner. This is an extreme amount of inrush current. We'll go ahead and see what happens. Listen close. It started right up. Okay, that's ridiculous. That is so cool. At the moment, we've got a pretty balanced load, not too bad. Let's see, let's go ahead and turn on another major appliance at the exact same time. We're gonna go ahead and turn on the electric dryer now, and it'll be interesting to see if it can run this at the same time. Obviously, an electric dryer is a pretty big load. We have a gas dryer upstairs. Not much point in testing that because that's not gonna draw very much in comparison to this. Here we go. All right, we overloaded it. Now you can see that it stopped at 3,500 watts on each leg. So that was just a little bit too much. So it's interesting to see what it does when it overloads. Let's go take a look at the unit and to see what it's telling us. All right, let's see if we can go ahead and turn it on again. We're just gonna click the button. Just like that, we are back in business. So it just overloaded and kicked itself out. As you saw there, for a few seconds, it was able to run the electric dryer and the heat pump at the same time. Even though it was over 6,000 watts, it was closer to 7,000 watts, but it was able to use that surge amount, that 9,000 watt capability. I think you can exceed the 6,000 watts for a total of 10 seconds before this thing actually will kick out and go into overload protection mode. Now with the way we have this set up right now, this thing is powering the entire property. It is powering my garage as well as the well house, which is really crucial. The well house is fed from that outside panel. But for a lot of people, you're most likely just going to have a main panel that's located in your house, in which case feeding this panel directly is going to be your best bet. And that's where a transfer switch like this can really come into play and work really, really well. This thing actually gives you the option of controlling particular circuits. So if you don't want to power the entire panel and you just have your essential circuits that you want to control, you've got two 240 volt breakers in here, a 30 amp and a 20 amp, as well as 6 15 amp breakers. The way that this works is you use the included wires that come with this thing, you run those in through a conduit into the main panel and select which breakers and circuits you would like to use through this transfer switch box. Once all of your circuits have been wired up to their respective locations, you can then go ahead and install your power inlet location. Now this is designed such that we can actually go ahead and put this right here in front of this transfer switch and connect our power inlet right to here. Or you can install this in a remote location. So if your transfer switch is near your panel, but you want to be able to put your actual off-grid power in the garage, you can then go ahead and mount this in the garage and run a wire from here to your transfer switch. Now it's actually really cool. We have two different meters right here that are going to show us how many watts we are using on each particular leg. And like we already talked about, having those as balanced as possible is really important. Here you can see it says gen, off, and line, and that's what these 3 position switches are going to give you the ability to do. If you want to connect this particular circuit to the generator or power source, you're going to put that up like that. If you want to turn it off, it's in the middle position. If you want to connect it to the standard grid input, you put it down just like that. This transfer switch is set up to use a 50 amp setup, so you can see we've got our 50 amp plug right here, which can connect directly to the 50 amp receptacle right here, and this is what the other end of that plug looks like. It kind of at first seems like there's only 3 conductors, but the 4th conductor is right here on the side. That is our ground. And this exact transfer switch and cord is actually one of the configurations that you can choose to purchase in the links below if you want to have this set up. One reason you might have to go with a transfer switch like this is that some jurisdictions don't allow an interlocked breaker and power inlet box like what I have at my location. So make sure that you check with the authority having jurisdiction as to what type of generator backup they permit in your area. Now, I don't think we're going to end up showing any solar input, sadly, right now. However, I did test this when I first unboxed it, and it was cranking away just as it should, because we did have a sunny day, and I was able to set those panels out in direct sunlight. So it does work fantastically, as long as your solar panel is in the sun. Real quick, let's go over the included ports on this unit. This first one here is compatible with the Anker SOLIX Home Power Panel, which allows you to tie in with the grid and solar, and then charge and discharge strategically. Right here we have our AC input of up to 1800 watts from the wall. Right here is our solar input of up to 2400 watts. Note that you cannot use them both at the exact same time. If you connect both solar and the grid at the same time, it's going to default to the grid instead of solar. Right here we have our expansion port to connect to additional batteries. You can see we've got it plugged in right now, going up to our expansion battery, and the expansion battery is going to have another port as well that can go to additional batteries. You can have a total of 6 of these batteries connected to one Anker SOLIX F3800. Here on the front we've got a car socket that is able to output 120 watts, as well as a button that turns that on and off for all of your 12 volt accessories that you may want to use. A Bluetooth button right here allows you to connect to the Anker app and control additional settings inside of this unit. We've got 3 USB Type-C ports with an output of 100 watts each, 2 USB Type-A with the output of 12 watts, a display button to wake up the display, power button, and a reset button. Now that brings us over here to the AC ports. We have a 1450R receptacle right here. This is going to give us access to the full 6,000 watts that this thing is able to output. Now this is actually overkill for what this unit is really able to do. It can't output to the full 50 amp potential because we only have 25 amps of 240 volts available from one of these units. But the convenience of having this is that it allows you to connect an RV directly that uses this style plug, as well as a car charger. A car charger you can connect to here and use up to 6,000 watts. You need to make sure you have a car charger that's variable output so that you can pull up to that 6,000 watts but not over 6,000, because by default a charger may just try to draw more than that 6,000 limit. Right here we have an L1430R. This is the one that we're currently using, as you can see, and this is able to also take advantage of the full potential of this unit since it's capped at 25 amps with the 6,000 watts, but this cord and receptacle are designed to handle up to 30 amps. Right up here there's a button that turns our AC on and off, so it turns all of these ports on or off depending on how you're using it. Now we've got 6 120 volt 20 amp receptacles. The 3 on the left right here are able to act as a UPS or uninterruptible power supply. The benefit to those is that you can connect a computer or other sensitive electronic devices to it and use this thing to protect those while having this connected to the grid at the same time. Now note that you cannot use the 240 volt while you are using this thing as a UPS. You can only use up to this many watts while you are using it as a UPS with these 3 receptacles right here. Interestingly, on the solar side of things, you can see we've got the 1,200 watts, 60 volts max input times 2, so your 2,400 watts of input with the full output capacity of 6,000 watts. So for whatever reason, it's limited on the grid side, but pretty much unlimited on the output for solar power input. Our unit is charging right now, and I just want to show you guys how the UPS outlets continue to function. So between the hot and the neutral right there, we have 122 volts currently, which is fantastic. However, on the 240 volt side, if we go ahead and check across the 2 legs right there, you can see we do have 0 volts. And that's just because, for whatever reason, when this thing is connected to a charging source, or the grid more specifically, it does not allow 240 volts to pass through. Let's go ahead and disconnect the grid quick and see how quickly our 240 volts comes back, and there it is. Now let's take our grid plug and connect that again right down here. And just like that, we lose our 240 volts. Right now we're charging from the grid at a rate of 1,700 watts. Turn them on, and then we're going to just see how long this thing is able to run. So we're at still 1,500 watts. There it did, it kicked out. So overloaded the UPS function, Other hardware features are these casters on the unit that make this thing much easier to move around. They're also able to lock. We have these larger wheels on the back that we can use in conjunction with this handle that pops out right here, where we can tilt it and more easily maneuver the unit since it is quite heavy. These rubber feet allow you to lay this thing on its back if you would like to, instead of having it standing up in the vertical orientation. This could be really useful if you're putting this thing into the back of the car or laying it down on the floor of your RV or camper, so you don't have to always have it standing up like this. Anker has designed this unit to be durable enough to use it for 10 years every single day, charging and discharging. It's using lithium iron phosphate automotive grade cells, which are capable of that sort of longevity. Another thing I really appreciate is that Anker is a well-known and reputable brand that has a 5-year warranty with the machine, so that's pretty fantastic. 5-year warranty, 10-year lifespan that they're expecting out of the product. Now, as the Anker SOLIX F3800 name implies, this thing has 3,840 watt-hours of storage capacity, and adding a battery doubles that with another 3,840 watt-hours. So between these two units, we have 7.68 kilowatt-hours of storage. This month so far, we are trending towards a little over 1,000 kilowatt hours. Taking that 1,000 kilowatt hours and dividing it by 30 days equals about 33 kilowatt hours per day. If I were to change nothing about how I use power at my house, we would take that 33 kilowatt hours divided by 24, which gives us 1.375 kilowatt hours per hour that I typically use. You take that 7.68 divided by that 1.375, and that gives us 5.58 hours of power from these two units, changing nothing about how I manage the energy at my location. Now, if we actually had a grid down situation, I can guarantee you that I'm going to turn off a lot of stuff. You know, anything that you have plugged into the wall, like a little transformer, it's probably drawing a few watts and just wasting that as heat. Like I checked actually on my Keurig, and when it's plugged in and turned off, it is drawing 3 watts all the time. So there's a lot of things you can do to reduce the amount of power that you're using. Now, if we were to max out this system with 6 extra batteries, that's going to give us 26.9 kilowatt hours for this unit plus 6 batteries. And then if you really want to max it out, you can double it again, because you can take one of these units and 6 batteries and get another unit and 6 batteries and combine the two for a total capacity of 53.8 kilowatt hours. According to Anker, you can make it 2 weeks on that 53.8 kilowatt hours, which is based on the average daily electricity usage during blackouts in American households. The other crazy cool thing about having 2 units paired together is that you are also going to double the amount of wattage that you can output to your property. So you can go from, right now, 6,000 watts at 240 volts, all the way up to 12,000 watts at 240 volts continuous with surge beyond that. Optimally, you're going to use solar power to recharge your battery as much as possible. However, if you are in a very cloudy location, or it's just not practical to use solar, or you don't have solar, what I'm actually thinking about doing for this exact location here is, if we have a power outage, I'm going to use the battery in the house as long as possible. If it drains to where I need to recharge it and I don't have enough solar, I'm going to take a generator and connect it to the inlet box, just like we have right now with the battery setup, and power the entire property with the generator. And at the same time, I'm going to recharge that battery in the house, and once that's fully charged, I can switch back to going with the battery as the main power source. So it would be a really convenient way to decrease the length of time you have to run on a gas generator. Now, for most power outages, you're probably not going to have to use a gas generator at all. If you have your battery charged up, it's not going to be a big deal. You're going to be able to just run for the 6 hours or 2 hours or whatever your power outage lasts for, and then the grid's going to come back on, you recharge, and you're good to go. We're going to go ahead and switch over to this generator powering the property, and we're going to do something kind of cool using a special cord that's going to allow us to connect It could be two separate 120 volt sources, but in this case it's going to be the same. So we're going to plug these two into these two receptacles right here. I'll link to this crazy cord in the description, and that's going to allow us to power the entire property with 120 volts through this same L1430R plug, which is really, really neat. The only thing that's not going to work is the 240 volt stuff. Anything that's 240 volts is going to show as having 0 volts, and I'm going to demonstrate that to you by testing these prongs as well as in here before we connect anything. Because if you connect two separate 120 volt sources, what you need to actually do is make sure that every single 240 volt load is turned off, because you can actually get some voltage like coming in and going out depending on if the phasing is lined up or not from the two different 120 volt sources. It's kind of a cool thing you can do. Let's go ahead and get this thing started up. The 123 volts there. Now we're going to check from the two hots to each other. It should be 0. You can see we've got 0. We should have 0 right here. 0. We're going to disconnect the power from the Anker SOLIX. Now the whole farm site has no power. And now we'll connect our generator. We'll go check out inside and see what everything's looking like. With the generator running outside, all of our 120 volt loads are being supplied in the house, so everything works except for 240 volt loads. And the benefit of that right now is that pretty much everything operates as normally, except for those 240 volt loads, and we can go ahead and recharge our battery pack while the house is still being powered by the generator. So we'll go ahead and plug that in, and we'll see right here, our input is going to go up. And we overloaded. So our poor little generator. We're going to switch back to being connected to the battery. If I had my bigger generator set up, this would actually work perfectly, because I'd be able to power the entire house with like a 6,000 or 8,000 watt generator, as well as charge up the battery pack at the same time. That little tiny one's just not quite big enough to really handle what we were asking it to do. Now, one other thing that I wanted to mention, right here I've got a propane line that I ran over here. Actually, my propane tank used to sit right here, and then I moved them way back into the woods over there. And so I have a 10 PSI propane line coming all the way to right here. And so I'm going to connect this to a propane generator. So if you want to see that video, make sure you subscribe down below. So having this cord run across my yard is not exactly optimal, but there is something really cool that I did. Right here, we have an extra set of 200 amp wire coming from the panel location all the way into the house right next to my main panel. It's just behind the drywall. So I could actually put a junction box on here and run these wires into my power inlet box through this interlocked breaker out here and be able to power my entire place from inside the house over there without having to have this extension cord running across the yard. Obviously, I wasn't really anticipating the fact that I might have a battery backup solution that wouldn't have to be out here. My original thought was just that this is the best location for a generator because it's far away from the house and you're going to have the least amount of carbon monoxide risk and all that kind of stuff. All right, we're going to go ahead and begin our capacity test. We'll go ahead and reset our meter here. We're going to go ahead and connect a load to it.
Look at that heat coming from it.
Does it feel nice?
Yeah.
If this was able to be perfectly efficient, we would be getting 7.68 kilowatt hours. Now there are some inefficiencies in the process, like the fans running. You can hear that they did just turn on. And so as those run, that's going to use some power, as well as the display if it is on at all. All those are factors, so we will keep all that in mind. Made a little update to our setup here. I actually have the smaller heater that we've got plugged in now. So far we have pulled almost 1 kilowatt hour.
1 kilowatt hour is equivalent to 3,412.142 British thermal units.
We're down to 13%, 1.7 hours left. It is the next morning. Let's see what output we've got so far. 5 kilowatt hours. All right, we are down to 1%, so it's fully depleted. I went ahead and pulled our heater out of our plug right here. We'll just go ahead and plug it into a different receptacle, and then we can see our stats. All right, 5.47 kilowatt hours is the total amount of electricity that we were able to pull from those batteries. So let's go ahead and switch back to the grid. We're gonna shut off the battery pack and turn on the grid. Yes, I do know. I'm gonna put one in there. I just needed a 30 amp breaker temporarily, so